how does VaryLaTeX work internally? So VaryLaTeX follows a quite usual process in terms of software product line and let's say configurable systems, in that you need to annotate variability. So what do we mean by annotating variability? Is that you use some mechanism to state which part of your LaTeX document is variable, is subject to variation. So here in these slides, right, we show how to use directives from a templating engine called Moustache, which is quite well known. It's really close to the use of the C preprocessor with ifdef directive, so it's kind of compile time directives. In this example, you have ACK, bold ACK, paragraph ACK, long ACK, but you can well also make vary the figure size or the vspace of your LaTeX document. So that's the major effort you should put into VaryLaTeX. And then you certainly have to specify what is the boundary of numerical options. For instance, vspace bib, it goes from 1 to 5, and the precision is 1 because we want 1 decimal digit precision. No need to have thousands of digits after. Otherwise, it's too complex, and there is an exponential number of values. So yeah, it's better to state precisely what the precision is to avoid such explosion of variance. Because even in this case, it's already huge. You have to combine all possible values together of numerical options, and it quickly leads to thousands of variants. Another thing you want to do certainly is to put some constraints between options. Like here we have GS script size, GS tiny, and GS footnote size. They are mutually exclusive. It's just one option among 3, because you want to choose one font size, not 3. So it's kind of obvious, but you have to state it explicitly, right? And so these 3 options are mutually exclusive. Some options are optional, meaning it can be true or false. Some options are mandatory for structuring a bit your variability model. And then out of this effort, VaryLaTeX is kind of automatic mode because it samples automatically. So there are different strategies we could rely on, but basically we implement a random one, hopefully a uniform random one. And then it selects for you a subset of configuration, not all of configuration, because of the cost and time needed to build each configuration. And then for each configuration, we call a script that builds the PDF files. Another thing VaryLaTeX does is that it observes some properties of the PDF variants, like the number of pages. And it can be 4 or 5 in this example. And 4 is a valid document in the sense that it respects the constraints of the call for papers, and 5 is a non-valid variant, right? And so at the end you have some configuration for which the label is valid or not valid. So it looks like a classification problem, a supervised classification problem. You can build a decision tree, a classification tree, or you could use many algorithms out there to resolve this classification problem. The goal is to find some patterns among options values that lead to 4 or 5 pages. Classification trees are quite interesting because they are readable, they express some rules that you can follow. And here we can quickly see that script size, which is a kind of font, right, should be set carefully because it has a direct impact on the number of pages. And then you have also the size of the figure and so on. And these kind of rules, you can reinject this knowledge and enforce constraints to avoid the setting of values that will anyway lead to 5, and we want 4 in this case, and can also assist the user in configuring the right variant. So this is the central effort, right? Annotating the variability. So I say you can use templating engine instruction or C preprocessor, like in this example. But what we did in VaryLaTeX, and that's a kind of new feature, is that we reuse built-in facilities of the LaTeX language with macros. We define some macros like if val or get val that allows us to control the values of option and have strategy to activate some portion of code or to set some specific values. So that's native LaTeX. So what's nice is that it's compatible with the ecosystem of LaTeX. Any compiler LaTeX will understand that. No need to have third-party tools like compared to, let's say, templating engines. And yeah, and at the end, the intent is the same, right? It's to annotate LaTeX with variability information. And you can do that for figures or for anything. We have made the experiments. We have the same kind of expressiveness as with the preprocessor. Based on that, yeah, as I said, you're trying to resolve a statistical supervised machine learning problem, here classification 1, because it's either 4 or 5. So it looks like a regression problem, but actually, as it is either 4 or 5, it's a classification problem because the class is valid or non-valid. And then based on that, you can what we call specialize the variability model. That is, you inject additional constraints because what you want is to authorize configuration that will lead to 4 pages. And this enforcement can be used by the user when configuring the LaTeX. Okay, so that's how VaryLaTeX works, and how is it implemented? I can give more specific details here. The URL of the project is now this one. It has moved. It's a complete rewrite of the old version. Now it is written in Python. And what's nice is that as a user, you just have to launch a server and then enjoy into your web browser the different features of VaryLaTeX, including the configurator and stuff like that. Yeah, so feel free to use it. It can import zip file, overleaf URL, and stuff like that.